Do you sometimes feel like your AI chatbot is taking forever to respond? Well, that's because the most AI works one word at a time. But what if I told you that there is a new type of AI that's up to 10 times faster? Today we are diving into the world of diffusion LLMs, and we are going to see the real-world example with Inception's AI Mercury model. Okay, so to understand the new stuff, we need quickly recap the old way. Most AI language models, like the ones behind ChatGPT, are called autoregressive. Think of it like this: they write a sentence one word at a time. Each new word depends on the old words that came before it. Every model has its context limit, which is equal to the total number of tokens in your question plus the AI response. By the way, tokens are not equal to the words, but it's easier to explain it like this. If you want to check how exactly text is represented by tokens, check out Tokenizer. You can find all of the links in the description. You can usually tell LLM how long you want the answer to be, or it will stop when it thinks it's done. This makes it flexible, but building word by word can be slow, especially for long texts. It's like laying the brick wall, one brick at a time. Now, enter Diffusion LLM, like Mercury. These are different. They start with a messy, noisy version of entire text, like a blurry picture, and then refine it all at once. Diffusion models can also use blocks to handle very long text. They refine each block separately, but in a coordinated way, giving them a good balance of speed and the ability to handle longer content. This makes Diffusion LLMs great for projects and tasks that require a lot of planning. This is Inception's AI Mercury compared with autoregressive LLM, with a counter of iterations that model has to recalculate to generate the same response. A diffusion-based LLM can generate the same Python function in only 14 iterations, while autoregressive LLM in 75. That's a huge difference. Now let's see this in action. This is a playground hosted by Inception's AI. I have a prompt that tests how well LLM is able to prepare a single-page HTML and JavaScript chat website with a few additional instructions. I will start the timer after I start generation of the response. I must say, this visual effect of diffusion text generation is very cool. And it's done. That was very fast, it took under 7 seconds. Now let's check if it works. And as you can see, it is working properly. Now let's check the same prompt but in OpenAI's ChatGPT. You can instantly see the difference. GPT is taking much longer to generate the response, because it is capable to generate only one token at the time, as every other autoregressive LLM. It took nearly 90 seconds to finish the job, so more than twice as much. And the final effect is very similar to Inception's AI. Of course, the responses are not the same length, so it should not be compared only by the time of the response, you might say. So I checked the token count for both responses in Tokenizer, and here are the results. ChatGPT generated 801 tokens in the response, and Mercury generated 1027 tokens. It was faster, even that it generated more tokens during the response. But we also already have fast autoregressive LLMs, like LeChat from Mistral AI, which is powered by Cerebrus hardware. Let's see how it will handle our chat prompt. Wow, that was super fast. Around 3 seconds. Let's check the result now. And yeah, it works very well. Additionally, Mistral Large generated 1348 tokens. Does this mean that diffusion LLMs are not needed anymore when we have hardware from Cerebrus or Grok? No, because the key point is that the algorithmic improvements in diffusion LLMs are independent to the hardware being used. This means that if you deploy them on the even faster hardware like Cerebrus, which is specifically designed for high throughput computations, you can expect the speed benefits to compound. In other words, diffusion LLMs should inference even faster on Cerebrus hardware compared to the speeds achieved on NVIDIA H100 chips, which powers the playground. Maybe it will be 1500 tokens per second, maybe 2000, and maybe 4000. I don't really know, but I can bet that we will see it very soon. So there you have it. Diffusion LLMs can make AI much faster and more efficient. Mercury is just one example, but it shows the incredible potential of this technology. And what do you think? Let me know in the comments. And if you want to keep exploring the cutting edge technology with me, make sure you subscribe, Let's dev it together.